Hey, g'day. Hey, I've had a change of plans. Originally I was planning on making a telephone spam call blocker, which I was calling PotGuard, and it's using a microcontroller, microDot, and a caller ID circuit. But I found Verizon phone service had a do not disturb function that it did exactly what I was trying to do. So I have decided to go down another route with my microDot project. I still want to use microDot to build a web server that runs on a microcontroller. So instead, I think I'm going to use it to monitor and control my vegetable garden. It's coming on spring here, so it'll be a good chance to up my gardening game if I ever had one. So this set of videos, I'll have a look at setting up a Raspberry Pi Pico in the garden. This will include creating a drip irrigation watering system. Do some monitoring of soil water conditions, some environmental monitoring, and have a solar power system. I'm not much of a gardener, so will not be spending too much time on looking at the actual garden other than showing what I set up. In this video, I'll continue with getting the microDot environment set up. I want to expose some web services that I'm going to be using for triggering a relay to turn on the watering system, to collect soil moisture readings and store logs of that data on the microcontroller. I also want to be able to check that I can host a basic Angular application on this microcontroller. So after that, in subsequent videos, I'll probably have videos on setting up the irrigation system, setting up the solar power to power the electronics, video on the Angular front end that I'm using to control and monitor the garden, and also have a look at how I've packaged everything up to make sure it's waterproof and can survive a year out in the garden. So here's the plan for the garden. So start with, I've got a raised garden out there. It's got soil in it. I'll probably clean up the soil a bit more yet, but idea is I'll put some tomatoes and lettuce and peppers and things in the garden. So the first stage of computerizing the whole thing is I'm going to add a drip irrigation system to the garden to get moisture to all the plants. And that's going to be driven off a big water bucket, because I don't want to run a hose out there all the time. That's going to have a pump on it. That's going to be relay controlled. So first stage is to be able to control the irrigation programmatically. I'm going to also add some I2C based sensors to the garden. So I want to put some moisture meters in sort of 4 locations in the garden to check how moist the soil is. They'll help with deciding when to turn the pump on and off. I also put some environmental sensors into that sensor, so pick up like the humidity, temperature. I'll probably get air pressure as well. That comes for free, just to monitor what's going on in the environment as well. So hot days, I may have a bit more watering than cooler days. And all those things will be connected to a Pi Pico W microcontroller. It's going to be running Micropython. That's what I'm going to have the microDot web server on as well. So that will be monitoring and controlling the pump, monitoring the I2C connections. So those will probably be sort of timed functions more than anything. As well, I'm going to have web services over all those things. I'll also be logging the monitoring. So maybe every hour I take keep a record of what the soil moisture sensors say and what the environmental detectors say, and log that away. And then I'm also planning on that Pi Pico with microDot to be able to host a Angular application. I've done this sort of thing before, so as long as I can fit an Angular application onto that microcontroller, that should be a good way of calling the web services that I'll expose through microDot again on that microcontroller. As long as all that stuff works, then I'll probably also need some power out there rather than run power out to the garden, which will be complicated. I think I'll do a little solar installation as well, solar panel, which I've got hanging around already, so I can use a spare 50-watt panel I have, which I think should have enough power for this. I'll have to add up the power budget once I get some numbers in. Solar control and a battery, and most of the time it's just going to be running the microDot web server on the microcontroller, and then sometimes it's going to periodically need to run the pump, which is probably going to be the heaviest use of power in the whole thing. I may even have a relay controlled webcam out there so I can keep an eye on bugs and things out in the garden as well. So one thing I want to check on is that I can actually host a Angular application in a microcontroller, so in the Pi Pico. So I'm just going to make a minimal size Angular application first. So I'm in my projects directory, so I'm going to make one called ng new, let's call it gardenUI. Now I'll put these up in my Git repository. So hit that. Now I don't want routing, I want to keep this as small as I can, so no routing, and I'll just use CSS. Okay, so let's go into that directory. And now I'll do a ng build just to see how big the actual distribution files are. Looks like total space used is 150 kilobytes, so we're probably in the ballparks for fitting it on a 2 meg. Okay, let's drop into the gardenUI folder using Visual Studio Code. Okay, so there's my Angular project. Let's just double check it's actually going to create a website. And we'll open it in the browser. So there's just the standard default Angular website. So it looks like we're good to go with that. So the only other thing to do is I want to put it under source control. So let's publish that as a public repository, and so it should be available up in GitHub. I'll put the link down below. So there it is. So I have the start of my Angular gardenUI project, and under distribution you can see the files. These are the ones I'm going to try and serve up on the Raspberry Pi Pico microcontroller. So let's get that going. So I'm going to open a new folder now, and I'm calling this one gardenPico. So at the moment that's just an empty folder. So let's create a, in this case, Pi Maker project, because this is all going to be Micropython, and I'll be developing against a Raspberry Pi Pico, so using PiMaker helps do all those sort of things. So let me choose the project folder that I'm using for this, for PiMaker, which is just the one I just opened. Confirm that. And again, I'll just make a empty project. And I haven't got a device selected yet, so let's save that for now. So I've plugged in my Raspberry Pi Pico. Should show up soon. Add devices. Okay, it found it out there, so I'll say okay. So there's my Raspberry Pi Pico. It's been discovered. So about the only other thing I want to do, actually I think we're all set here. I can see my project, I can see my files, I can see the open editors. So let me save. Save the project. And this one I'll also put under source control as well. So let's click on source control, publish to GitHub, and out as a public item. And if I open GitHub, I can see the start of this project going as well. So let me go over to the Explorer view. So much like I showed in the previous video, and I've got a link to that previous video where I went into a bit more detail about using PiMaker and microDot. So in the boot part of the Micropython code, this is where I'm going to connect to Wi-Fi. So let me paste in that code. So this is the code I've got in boot. So I'm importing network and time, connecting into my Wi-Fi with the correct SSID and password. What's different from the last video is I've actually set the IF config, so it's got a static IP address now, and I'll show in a sec that I'm going to set that up in my DNS to be the name of garden, so I can just find this this device whenever I want by the network name rather than having to put in the IP address. I connect up, wait for the connection, and then it should tell me that it's connected at that point. So let's try running this and see what we've got. So I'm connected via COM8 to this Pico board. Let's upload everything to the device. I'll go into REPL, so let's open the terminal. And I'm going to do a Control D, which should get it to reboot. So that's good. It connected to my Wi-Fi, and there's the IP address it's assigned, which is the one I gave it, so it's got the static address. This shows how I set up that garden host name on my Fios router. So first I went into DNS server, set it, and added a new server address. So I called it garden, then I put in the IP address I chose for it, and then I tested it out by using a ping just to make sure it could find it. So I made some changes to my boot.py file. Mainly I just added in this getting the NTP time, but I noticed there's kind of a bug there. Sometimes it doesn't get the time in time and it throws an error. So really I just put it in here, a try, and if it fails it goes and reboots the process again. So that's all happening in boot. So sometimes it takes 1 or 2 boots to get through the boot sequence and get its IP address and getting the latest time off a NTP time server. So the majority of the code I just added was for microDot, and this follows mostly the pattern I had earlier in the video before this one. One thing I've done is changed from microDot to microDot asynchronous. So this allows asynchronous processing, so I know I'm going to have other things going on at the same time as the web server is running. So to make sure the web server microDot doesn't block everything, I use the asynchro version so I can run other processes. So I'm going to have some timing functions to do logging, periodic logging, and turn the water on and off in the background, as well as having the web server running. So that's why I'm using this microDot asynchro. So when I do that, I again just declare an object for that represents microDot. I've put these route decorators in to tell microDot what to do. So what I'm doing for this test is pretending I've got the relay connected up to the pump that's going to pump the water through my drip irrigation system. So I'm calling that web function pump. So by default, if I just ask for /pump, then it's just going to return the current value for the pump, whether it's on or off. And the other choice is the route, where if I provide pump but with a parameter of either on or off after pump, then it's either going to turn the pump relay on or off. If I give it any other parameter as the value, then it's just going to say not found, return a 404. And otherwise what happens is, again, this is in the main routine, so automatically gets started every time the processor gets started. So after the boot.py code's being executed, it'll go into this main code and it's going to try running the app. And this time I'm running the app with the debug flag on, so I can see what's happening as it receives requests. And I'm also assigning it to port 80. By default it uses port 5000, so port 80 is more useful for the production application. I just print a notice that it's up and running. And this except here, so if I do a keyboard exception, so if I push Control-C while this is running, this will break out of this code, which is really useful seeing this is in main. I don't want the thing to carry on running and rebooting, so I want a way of interrupting what's running so I can debug it. So if I do a Control-C, it'll break out of this, and you'll see when I test this out that it allows me to exit this code, and also while it's executing, it shuts down the app, which is the microDot web server. So let's try running this. So I'm going to go into REPL and do a Control-D to do a soft reboot. So this time it all worked successfully through the boot routine. It got the IP address set. It also retrieved the current time, which is the UMT time. So at the moment I'm in Eastern time, so my local time is 9:28, but you see the GMT time is like 1:28. So we're going pretty good. And then it's said it's gone and started the async server, so this one here has been executed. So let's try. So first I'm just going to send a command to, again, my host name is garden.home is what my local network's called. So garden.home gets me to the 192.168.140 address, and then I'm just going to send it the route of pump. So let's see what happens. And it returns JSON saying the pump is currently off, so that's the current status. If I say pump on, so that I could hear my relay click, and now the pump's turned on, it returns this JSON saying the pump is on. If I do off, it turns it off. If I turn it on again, and then if I send it with at this level, again it just returns the current status of the pump, tells me whether the pump's on or off. So that's working okay. Let's go back to our code. So you can see here, because I had debugging on, it's also given me some debugging information, that what worked, what didn't. And again, if I do a Control-C, this will break me out of that running program, so it allows me to get back to coding and make any changes I want. Okay, finally for this video, I want to get my Angular application getting hosted on the Raspberry Pi Pico through microDot, and also add some code to the Angular application to call those web services, so I can use a nice UI for turning the relay on and off. So just got File Manager up here, and on this side I'm looking at my gardenUI, so my Angular project. In the distribution folder it's got the gardenUI distribution files, so let me pull those over and put them in my gardenPico Micropython project. So now when I look in my project here for gardenUI, it's got the distribution files for my Angular application. So let's see if we can get microDot to serve up these files when someone connects up to the garden.home URL. Okay, just before I go too far, let's just look at the space usage on my Raspberry Pi Pico. So nice thing is when you roll over in PiMaker, when you roll up over the device you're using, it gives you information. So we see down the bottom, it's got that FS blocks total, which is the total amount of file space available in blocks. So our block size is 4096 bytes. We've got 212 blocks in total, which works out to be 868K of available free space before we do anything, before we install our Python files. Now, the Raspberry Pi Pico has actually got 2 meg of flash memory, but a lot of that's been used up by the actual MicroPython interpreter. So again, we've only got 868K available to us to play around in for programming. And you'll notice down there that our FS blocks free is set at 190 at the moment. That's because I've used some of that free space for my actual application, what I've loaded up there so far. So the main and the boot and the microDot async.py and the microDot.py files. So it's reduced to 190 blocks available, which turns out to be 778K of available space. Now the thing I was worried about is how much room is the gardenUI Angular application use up, and we saw when we built it that it was using like 160K. I've brought those files over, so let me go and do I'll save it. Let me deploy that up to the Raspberry Pi Pico. So this is going to be a little slower because those files are fairly big. So deployed, so I've used up some more of that free space now. So let's have a look at the size now. So it's still showing 190, so to get it to refresh I've got to disconnect, reconnect to that device. Let's see, we're down to 140 blocks free, so 573K left after uploading the Angular application. Now my final Angular application is probably going to be a bit bigger than that, but I'm feeling comfortable that I've got like half a meg of space still left on my file system on that Raspberry Pi Pico, and I'll probably use maybe 300 or 400K of that for the log files, from maybe keep about a year's worth. So assuming I have about a K of log files each day, then that should be in the ballpark for the space I've got left to play around with. Okay, so I'm adding the routes so I can retrieve the static files I've got under gardenUI. So a couple of routes I've added is first the route just when you get a straight high-level / come in, then it's going to serve up, it's going to send back the file gardenUI index.html, which is that one there, to get everything started. And then when it wants to retrieve these supporting JS and CSS files, then it'll see these requests come in from the browser. So basically a / with a path directive to the file it wants to retrieve, and then it's going to send back that gardenUI or the content under gardenUI with that path directive. So let's try running this. I'll do a Control D again. I've already uploaded it. So the server's up and running. Let's go to my browser, and I'm just going to put in the URL of my Raspberry Pi Pico, and that looks good. It's served up my Angular application from the Raspberry Pi Pico, so all that's working. Let's just go into our project again, and we can see from the debug information that it's retrieved the top level index.html, and then it retrieved the supporting JS and CSS files. So jumping forward a few hours, I updated my Angular program to get a better idea of what it's going to look like running on the actual microcontroller, as well as making sure the relay functionality would work. So this is kind of how I'm thinking it's going to look. The graphics are just things I hacked together, so don't look too closely at that. I'll update it and have a nicer graphic here. But my idea is that you go to the Garden Home web server, so you can see this is running off the microcontroller. I've now got 3 tabs there. I'm using material under Angular to get things like animations going, and using some of these special controls like the slide toggles here, so it looks nicer. And this is my thought for how the final application is going to look. So I'm going to have this sort of green graphic that represents the actual raised garden. So sort of raised garden will be that shape. It's going to have 4 areas where I'm going to have moisture meters, which will read out the current moisture level in the soil. Central area, I'm just going to display some environmental information, so I'll have a little sensor there that picks up the temperature, the humidity in the air. I'll just keep track of the battery level, and also the water level in my irrigation water tank. And then I'll have a couple of controls here for turning the water pump on, turning it off, turning the camera on, turning the camera off, so I can look at the garden remotely. And then I have these other tabs, so the history tab, and I haven't done anything on this yet, but this will retrieve information, logs that I've stored away about things like the moisture levels and the amount of watering that's gone on, so we can look at it in graphs. And then the settings will be where I set settings. So for things like turning on the water for irrigation, I'll have a default setting for, say, have it run for only 5 minutes anytime I do that, or put X number of litres or gallons of water on the garden when I turn it on, and then have it automatically turn off again. And then settings for automatically running the irrigation, say when the moisture level's at a certain level, or when maybe just once a day running the irrigation for a certain amount of time, so I don't have to do it manually. So all those sort of settings will be looked up after here, but I haven't done that part yet. So let's have a look at how the Angular application's been updated to do all those sort of things. So you see now my Angular application's a lot larger. I brought in using material, using the HttpClient. Also you see in the app module here, I've brought in the material tabs module, material slides toggle module, so added quite a bit of size to it. It's actually, when I build it now, it's up to 500k, which is getting close to the limit of amount of spare file space that I had on the Raspberry Pi Pico. But I've got some plans for how I can get around that problem. So I probably need a bit more than, I've only got about 150k left of space to put the logs on. That really won't be enough for the number of logs that I want to make and store away on the Raspberry Pi Pico as well. So I've got to think of something to get around that. But let's look at the coding I've done. So like I showed before, there's now a tab interface. So this is set up in the app component. So this is the first component you hit when you start up the application, and this is how the tabs are laid out using materials tab control.
each one of those tabs expose another component. So like the garden component, the history component, or the settings component. So those components are now set up here. So you see garden, history, and the settings components are there. Really, I've just been working on the garden component here. So this now has a lot of code for showing that image we saw and overlaying the controls and the information. I've also added a service, and this is how you normally do services in Angular. So created this relay service here, so that's going to interface to the relay web service that I showed you just earlier that microDot was exposing. So for things like when I call the service to turn the pump on, it's calling the actual web service on the microcontroller with the pump on command and the pump off command, and also one to get pump state. So those services are now linked up to the Angular application. Just note that I hold the host name for the garden host in the environment settings. So again, in Angular, you've got these environments for the test environment and for the production environment of your code. And at the moment, I've just got garden host is representing it for me, the garden.home host name. But other people may have different names for that, or I may have changed the name that I want that Raspberry Pi Pico to have in the future, so I can just change it in one place by doing it that way. So most of the other work here was done in the actual garden component. So this is the HTML for the garden component. Not a lot of HTML, so it's using a lot of CSS to get the layout that I wanted. So first is a outside div tag here, which has a class of garden view, and then if we look at the CSS for that, garden view is set up as a background image, and that's what's showing that garden image with the green garden and the pump and the camera. And I set the size and some properties about that garden view, and then the rest is CSS classes to define where things are shown or overlaid on top of that garden view. So I had to do some calculation with the image to work out where those things should go, but this all seems to be working okay. The other thing to notice with the HTML is for this pump slide toggle. So you saw earlier where I slid the toggle for the pump, and it turns the pump on and off. It's using the slide toggle to do that. So two main properties and associated with that. One is the check property. So depending what the value of pump is in the code here, so there's a variable called pump, it will set the toggle to that value either on or off. So it will either be checked true or unchecked, where it'll be untrue when it evaluates this condition. And then the other property or event that I linked to this slide toggle is when a change happens. So when someone slides that toggle, it calls the code called on pump toggle and returns the event to that code. And if we look at the TypeScript code behind this, we see we bring in the relay service that I just showed you a second ago, which has the web services for controlling relays and the pump in this case. Then on init, so this is the first thing that happens when this component's opened. It's going to call the pump state service, and it's going to set this pump, which is this pump variable here, to whatever it returns, and it's going to return either on or off depending on the state of the pump. And then down here, this was the event associated with the toggle switch for the pump. So depending on whether I turn it on or off, the event's going to return here. Then I can interrogate that event, see whether it's been turned on, where it'd be checked, or off. If it's been turned on, then I call the relay service pump on service, web service. I subscribe to the result, and then that result's also going to return what the current value of the pump is after that service is executed. And again, set the pump variable to that value, and then the same here, but for the pump off. So the size of my Angular distribution files were increasing. I started at 150K. I added in HttpClient, got to 165K. Added in material UI components, got to 313K, and then added my code, so I was up to about close to 400K, which is bigger than I was expecting. So when I deploy it to my Pico, you see I've only got 262 kilobits free, which is really not enough for my log files. So I decided to try swapping over to ESP32. It's really not much to do here other than just plugging in the different device. And you can see here when I've deployed the code, because this is got 4 meg of flash, I now have 1,368 kilobits free. Should be plenty of room for log files and size increases in my Angular program, so I'm probably going to go with that.